At FineHomebuilding.com, we've taken our 40 years of experience publishing an expert-written magazine for architects, designers, builders, remodelers, and do-it-yourselfers, and used it to build the best online membership available to anyone interested in high-quality, high-performance homes. With an all-access membership, you can read 40 years of FHB print issues, watch hundreds of in-depth how-to videos, follow the annual FHB house build, plan your next project with our new project guides, and much more. Visit FineHomebuilding.com to sign up for All Access, the most important tool in your toolbox.
Whenever people add insulation to the inside of a masonry structure, then they block off that breathability of the building, and then they get mold. But the mold also occurs when the building's been repointed with harder mortars.
Welcome to the Fine Home Building Pro Talk podcast, our regular discussion with building industry professionals. This is Senior Editor Mark Petersen. Today I'm joined by Bob Kelly, Restoration Specialist, Inventor, and owner of WickRight Inc. You can find the Fine Home Building Pro Talk podcast and the original Fine Home Building podcast at finehomebuilding.com/podcast. You can leave feedback and ask questions there too. Hello, Bob, and thank you for joining us today.
Hey, Mark.
It's good to meet you. I've heard a lot of good things about you. You were recommended by Mike Gerton and then several people after that. So, yeah, it's going to be. I'm looking forward to our conversation. For starters, tell us a little bit about your background. How you got into the construction business? What you're doing now, how your kind of career evolved, what you're doing now, and then tell us a little bit about, you have a system of products, a line of products that you use on the jobs, and I'm assuming that you created these through the type of work that you were doing. So I'd love to hear how it all got started.
Okay, well, I was trained by a gentleman who did everything from scratch. So we did Victorian restoration jobs. We ground the knives. We put the foundations in. We learned how to solder the copper when we did old buildings. And that, when I went on my own, I took that philosophy of everything from scratch forward into my own work. So as years went on, I found myself discovering little mini inventions along the way, thinking I could, capitalize on these. But one client told me one time, he says, Kelly, these are great ideas, but they're good for one job. They're all one-offs.
Right.
So I've always been thinking about that thing that was not a one-off, kind of lurking in the background. So I would say when 2008 came along, and the work was just, how it was, right?
I was a builder at that time, and it was, people say recession. It was a depression in our industry.
It was a depression. So we've been doing a lot of great artistic type work. But there was the common element that started to show its head was water intrusion. The buildings from the boom were all built from a really porous material called split face block. And so all these water issues, and then finding condensation and water at the rooftop level, always been kind of gnawing at me. So the reason why I lead in with the 2008 was because there was a guy who was sending me a lot of work. He's actually spoken at Steve Breck's summer camp before. He's like, well, I can refer all this crap to you. There's no more cherry libraries. The last trim job I did was a $500,000 ebony inlaid staircase,
Awesome.
Yeah, it was cool. Well,
but yeah,
no more.
I had this very similar experience. Yeah.
So as we've started finding more of these things and try to come up with a solution, I was experimenting and learning about how water dissipates in masonry. I did a job one time where we threw water on the side of a building. It was the wetness was about that big. Inside, the wetness was that big, and even
so it expanded and it went in. So are we talking residential mason houses made of masonry? Or are we talking commercial or both?
Residential.
Oh, okay.
Yeah, and everything is built out of cinder block. And that's it. All you get, your siding on your cinder block is actually paint.
Oh boy.
or
Yeah.
some kind of sealer. That's all we have.
Yep.
So I did an experiment. I created a gap between the top of the wall and the bottom of the stone, and a gap between where the roof turns up on the inside of the parapet wall, and creating air gaps. Well, it just so happens that that house happened to dry out. The mold smell left the house.
So
And
did it have it was a stone cap, you said, not a like a metal flashing cap?
it was stone cap.
Okay.
My buddy he's a home inspector, Kurt Mittenbuehler. He pulls back the stone on a hot day and gets a blast of hot, wet steam hitting him in the face.
Really? So it was just cooking in there.
It's just cooking. And when he remembered, I did an experiment on this other building, having an oversized metal coping, hoping that the moisture would come out of the building. Then the year later, we did that. The whole house dried out. And then the year after that, we did a similar application. The whole building dried out. And then now we're up to about 80 buildings, realizing that when we create a gap, everything comes out.
So So let's start. I'm not super familiar with I've done very little with houses that are, I've seen, we've done brick veneers and that, but nothing really made out of CMUs or cinder or split face. So can you just kind of describe what are the most three common ways that the buildings that you're working on are constructed? Not only just what they're made out of, but how are they insulating these buildings too? Are they filling up the cores? Are they putting foam on it? What are you seeing most often?
Okay, well, the three typical envelopes that we see are CMU, CMU with brick, or common brick. That's it in downtown. We seldom work on any frame houses anymore.
Okay, so then we're talking like 2-3 story houses or buildings that are probably residential apartments or condos or
condos, single family, 3, 6, 12-unit buildings. Yeah,
gotcha.
The insulation in these places is either fiberglass bats or it's blown in fiberglass.
So where would the bats go on a wall assembly like that?
Right up against the cinder block. Typical framing on these homes is
on the interiors,
2x2s nailed to the block, and then the infill, 1.5 inch insulation, plastic, then drywall. That's a typical envelope.
Okay, so that's how I'm originally from Minnesota, and that's basically how we finished our basements. It was back in the day, we'd frame up a wood wall against a cinder, against a block or a poured wall, and we'd put bats in there and cover it with plastic, and it was a really, really bad. It turned out to be a really bad way to do it.
Sorry.
Go ahead.
We don't fill. I don't see any insulation filling the cores. I know that's
okay. So most of the time, it's and when you see a CMU, and I think you mentioned split face, are these core? Are these hollow? They're hollow walls all the way from the top to the bottom. Nothing core filled, really.
Every 40 inches, there's supposed to be a filled core with rebar.
Okay.
From top to bottom.
But that's from top to bottom. So they just, as they go, they're just kind of pouring as they go. Mm-hmm. And because, you can't pour from the top and expect it to make it all the way down, I would imagine. So, but the vast majority of these wall assemblies are hollow masonry.
Correct.
So when you go to when somebody calls you and says, Bob, we got problems, what kind of problems are they usually experience? Is it water infiltration? Is it mold? Is it poor efficiency? Is it smells? Is it, is it all of the above?
All of the above. So,
okay.
So when I take on a client, and they tell me that they're having water issues and they describe the structure, so I won't come out and right away give them a price. What I do is I kind of herd them in and I try to structure the approach to how to fix the building. So I'll develop a report that kind of itemizes all the immediate water ingress issues, and then if they're willing to pay me to come out and do an assessment, because now every building I know, this is all the same to me. This is just for them to be educated.
Sure.
Get them in the path of understanding the bigger system that masonry is porous and needs to be vented and sealed.
So, and you have enough of these under your belt where I'm assuming there's neighborhoods or there's certain vintages that you know where these houses are, and you can probably guess exactly what's going on before you get to that point, I assume. Are you still, I mean, are you still getting surprised at all, or is it pretty much you're seeing the same thing over and over again?
No, I'm not surprised anymore, because every masonry envelope needs some type of vapor release. Every masonry building ever built needs a vapor release mechanism, is what I've discovered.
And that's at the top, and it's always at the top. Is there something you do at the bottom to allow it to airflow? And it doesn't matter that there's nothing at the bottom?
There's no air intake necessary, because there's a few things happening at the same time. It's interesting because once you create a drying effect on the top of the building, natural wet to dry will always take over. Now, when there's wind blowing through the flashing, that just accelerates the process. So it creates negative pressure as the wind is blowing through. I should have some drawings to share with you. We have drawings on our website. The bottom line is that
we'll for sure link to your website too. Yeah.
Okay. Well, the bottom line is that we've substituted the mortar joint with corrugated plastic
on the cap.
Yeah, at the cap level.
So regardless if it's, I mean, are you talking, you do that whether it's a stone or a metal flashing cap?
Absolutely. We found that, everybody's using corrugated plastic in their rain screens.
Sure.
So we take strips of corrugated plastic, we laminate them to the bottom of the stainless steel drip edges, and we put a waterproof layer on top of that, so that plastic supports the weight of stones. It can support up to easily 6-inch thick limestones. And when the wind's blowing through, it naturally draws the moisture out. And then with water vapor rising, it's going through all the solid bond beams anyway when we have a drying effect. The only thing that inhibits our drying effect is that if the lower floor is down, when there's foam insulation in place, then the water can't get around the through-wall flashing or past the foam, because it's a stop right there.
So the foam, as far as there's some type of horizontal layer of foam that's preventing you to air. What do you do then if you can't get to the lower stories or the lower story?
I'm working on that. That's like, it's funny because I was talking to a friend of mine. Do you know Mark Willey?
The name rings a bell, but no, I've never met him.
He's active in Passive House quite a bit,
okay.
And he calls it filter glass. Okay, so fiberglass is really what's going to save all these buildings, because the water vapor was able to travel around to the interior and then up through what I call an interior rain screen.
Oh, okay.
So that's what I'm trying to create at the very top of the building, and using the insulation as it's almost like a drainage plane. But ideally, I would like to engineer that drainage plane, and then you can insulate all your foam or rock wool or whatever up against that, just to create that drying path, because masonry needs to expand 3-dimensionally, drying. And so if you can't do that to the interior, you get this weird hydrostatic pressure that just never dries out. And then when the sun hits it, then the sun forces all that water vapor through everything, including buildings that have spray foam.
Even closed cell, it'll go even with closed cell.
Yeah, it's disturbing that I see buildings that are 1 year old or 1 to 3 years old, and they have foam, cinder block, and a dark elastomeric coating, and the humidity levels are hitting 80%.
Ooh. What's happening in the winter? Is this more of a problem in the winter or summer? Or is it just a year-long problem?
Year-long problem. You get high humidity in the summertime, and then in the wintertime when we're seeing cracks through the masonry, but the cracks start at the through-wall flashing at the different floor levels up the building, because that shows that the walls are literally filling up with water.
And and it sounds like you can pretty much guess from experience what's going on, but just to, I don't know, maybe this isn't a thing. Do you have certain tools or techniques, or what are you looking for when you get to a project to kind of confirm what I guess your guess probably was before you got there? Is there FLIR infrared, or are you looking for effort plus, or what is it? Efflorescence. I have a hell of a time with that word. What signs are you looking for? Is it just the smell? I mean, is it just kind of obvious?
I smell it. I look at the efflorescence. I look at the flashing details. I've got a Flare 890. It's a nice compact hygrometer, because I use that to measure the moisture content in masonry before we apply any sealants. So that's brought into line. But now it's, you just have to stand back across the street and you look at the building, and it's the same as everyone else. It's just I try to find out how much insulation is in the building, because I find that buildings with less or poor insulation are actually surviving better than ones that are tight in this construction. And
you mentioned that a lot of these you're having problems with. I looked at your website and I saw a bunch of the projects that you were working on, and it was hard to tell really what vintage these buildings are. Are you having? Is this issue more of a problem with newer buildings, buildings that have a certain area, really old buildings? What era is the problem era?
The biggest problems are buildings less than 30 years old.
Really?
Mm-hmm.
And what's the difference between a building that was built, let's say, in 1980 versus one that was built in 1880 or 1920, something much older than that?
Okay, I'll try to make this quick, because it could get really long. So
long isn't bad.
Okay, well, the original structures are made with pure lime and sand, no Portland cement, because these buildings are the marketing and sale of Portland cement.
Yep. And so it's all and you're talking. Are you just talking the mortar joints, or are you talking the actual masonry units too?
No, just the mortar joints.
Just the mortar joints. Okay.
Yeah. And then of course the firing process on clay brick was with coal-fired furnaces, so the temperature's not that hot, so they're soft and highly absorbent. Mm-hmm. So the lime mortar acts like a poultice and sucks the water out of the clay brick, and then that's what exhausts out to the sky. Okay, so that is a natural occurring event. Now you have no insulation, so the brick is able to dry three-dimensionally in the same manner, and then the water vapor rises to the interior and it dries out. Now, this is also why when, you see parapet walls that needed to get rebuilt, it's because the water vapor it's all trapped underneath all the roofing materials and the cap. And then the moisture washes out, basically, what's the correct term? Calcifies, or it basically washes out the lime that holds all the sand together. So now with the newer buildings, well, that's the problem. Now, when people repoint these buildings, that's when you see bricks falling. Mm-hmm. Because the mortar joints are actually too hard, and they've reversed the drying mechanism. And another problem.
So the mortar joints in the old lime-based mortar is, instead of it just lets air move past through it, so every single layer basically has its own little venting system, so it doesn't all get trapped at the top and rot off that parapet and the whole roofing structure.
Exactly. Well, and they also have a long sloping roof, so that you got these little mini attics in these flat roof structures. And have you ever seen where they have bricks on the sides vertical, like a little brick window towards the front?
Yeah. Mm-hmm.
Okay. Well,
so you're talking like a soldier course of brick?
Right.
Yep.
That's your vent. Mm-hmm. And also the big ornamental cornices at the front of the building, and as all the water vapor is rising forward and up, those cornices are the venting mechanism of these structures, so that all that vapor is rising and is getting out.
Was that by design, or did they just get lucky on that?
I think they got lucky.
Yeah, which happens. But it's one of those things. If it keeps working, then let's keep doing that, right?
Right.
So do we know better now? I mean, so you're coming to buildings that were built. So it is both buildings. It's old buildings and newer buildings that you're working on. But it sounds like the reason you're even showing up at these older buildings is because they've been repaired with materials that they shouldn't have been repaired with. Is that fair?
Exactly. Yeah, we did an experiment one time with it's an old building that was redone. It was redone with type N mortar on the outside, so they repointed the whole thing beautifully, but it was too hard of mortar. And then they blew 2-pound foam to the interior of that wall, trying to do this great job of sealing it up and insulating it. Mm-hmm. Well, what happened was that they successfully locked in so much water that the air conditioning actually shut down. The house is waterlogged. It wouldn't perform.
Huh.
And the only thing that I knew to do was to take off the clay tiles, remove the mortar. And then we take this black fabric that's got a perm rating of 108. You can almost, when you look up to the sun, you can see through it almost, but yet it'll hold a glass of water.
Oh.
Now,
So
I hate
is
to
it
say
is it like a Tyvek product where it's more of a chemical I mean, a lot of the WRBs just have poke little holes in there. Where I think Tyvek is more of a chemical type exchange. Or
it's simpler than that. It's the
oh,
same fabric that's on the bottom of your couch.
same fabric. I'm not really familiar with the bottom of my
Well,
couch. What?
you know that black fabric on the bottom of
Yeah.
a spring?
Right.
That's the
So
exhaust.
so
So
it's just is it a woven? So it's a woven type thing. So it's a water surface. I mean, it's a surface tension that's basically not letting bulk water through.
right, but it lets water vapor through aggressively. So
Okay.
in this particular job, we ran a piece of plastic down the middle of the building, down the middle of the wall, like an 8-inch wall, or no, 12-inch wall, 3-inch plastic. We used that like a tent. And I glued that fabric on top of the wall, and then I took the clay tiles and glued those back down with like 4 blobs of polyurethane and
Mhm.
caulk fell. Well, a month later, I get a phone call from this guy saying that his extension jambs on his windows warped off the wall, and there's a musty smell behind there. What happened was that when we released the pressure, when we released the top of the building, all the water vapor rose out of the structure, and then the air conditioning came back in.
So what was the warping? So warping was the water leaving that
Was
wood?
was the water leaving the building?
Huh.
It just so happens the windows are just a hole in the wall, and he could smell the moisture after once the water started moving upward towards the sky. And that was a pretty stark example of how moisture moves through masonry.
So when does if you show up at a job, let's talk a little bit about your product that you create and your company. Are you, when you show up to a job and you can see clearly what the problem is, it's all this vapor is trapped in between these cavities, and I'm sure it's not just a simple matter, but the main fix is to allow this vapor out, and that's where your products come into play. And you mentioned them a little bit. It's kind of a system, a venting system, and the corrugated, just allowing. So, go into a little more detail on how the whole system works.
Let me see if I can go up on the camera better. So,
okay, what am I looking at? So it looks like a piece of flashing, 2 different types of stuck to the bottom corrugated plastic. Oh, there are holes in them.
plastic.
So it's similar to what you would see. I don't know if you ever had a yard sign or a political sign. It's like that corrugated plastic that has the little holes in it. You put the little fence post up into it, right?
It's exactly what it is. Because I was perforating 2 layers of sheet metal so that the water vapor would go through the bottom layer of sheet metal, and then the top, it was engineered so that we had a 1/2-inch gap in between, and so that's how we found out to dry out buildings in that manner. But
Mm-hmm.
I was taking the stones off of buildings, so anyway, I kicked over a yard sign and realized that was a nice hollow.
Right. So I was right on the mark then. What is
Right
it?
on the money.
So hold that up a little bit higher again. So I see 2. So do you just like skip tape them on, or so it's not one continuous layer of corrugated plastic. It's just like chunks or rows of it rather.
It's a continuous row. So the drip edge, when you see it from the outside, the stone is sitting on top of the sheet metal,
Mm-hmm.
and underneath it, in lieu of the mortar joint, is a continuous 5/8 thickness of 3 layers of 4 mil plastic.
Oh, sure. Okay, gotcha. I see. So it's in the middle. So there's a gap in the middle. There's one on each end, and the air can come up through the middle and exit through. Gotcha. Okay, I'm following that.
Okay.
Yeah.
So now,
if you're listening, that might be hard to describe, but yeah, if you can picture 2 small strips, maybe how wide are they? Inch, 2.5 maybe?
1.5 wide.
Okay. Yeah. So one goes on the outside of the CMU, I assume, and the other goes on the inside, and then the open is in the middle, and the flashing sits on that, and then the capstone. If there's, a lot of times there's not a capstone, right? So if it's just a metal cap, it would sit right on top of those. Same thing.
If there's a metal cap, we have a similar configuration. But what we're doing is, for a metal coping, we have 2 pieces, one on either side of the wall. It creates basically a 1/2-inch airspace.
Mm-hmm.
and it's routed out so that air can go through it, but yet we're not cutting all the way through the corrugated plastic because the ribs are still intact for support.
Oh, I see. Gotcha. So you just does that come from the manufacturer, or do you literally just take a solid piece and you pull out the guts of the one side or the middle?
We take a solid sheets. I run it through my my power feeder and my router table and dado blades, and then I put it all together. I've been using zip tape as the hinge. It's a great hinge.
And as you described earlier, the venting that, or the flashing that, keeps the bulk water out, it's still air can flow through there and pull out that moisture. I mean, that's kind of the whole concept. The last thing you would want to do is have that counter flashing or that flashing caulked on the edges, because that's not what you want. You want the air flowing through that top assembly.
Yeah, you're capturing everything. Now, I've got an Instagram account where the last post I had, my Instagram account, if you don't mind me saying, is Bob Kelly 6112. So a buddy of mine has an older building, and it's very common to see a waterbed right at the cant strip, because that's where, the southern exposure.
Say that again. And you had a waterbed where?
At the cant strip, and that's the triangular piece of insulation that you stick on the inside corner of a low slope roof.
Okay, so sure.
Right in that spot is often a place where water vapor accumulates, even in a dry environment. It's just difference in temperature. I ran my pocket knife through the cant strip on his. I could see that there was some squishiness. It was like a small waterfall that came out of his roof.
I actually watched one of your videos where you just to demonstrate how much water is can accumulate in these walls. You drilled into a mortar joint and water just pouring out of there.
You saw that one.
Yeah, that's a pretty good demonstration.
It's scary.
And that's not, and I think when people would see that, they would say, hey, you got a leak somewhere, you got to fill up a crack, and they think it's bulk water getting in there. And probably very little of that was rainwater getting there. It was just moisture. Well, I mean, it's rainwater in the fact that it's wetting the bricks, but it's getting sucked to the inside of that cavity, correct?
Mm-hmm. Yes.
Yeah.
Exactly.
Yeah, that was a pretty good demonstration. And how much water do you think came out of that? Just one?
10 gallons.
Yeah, that's just crazy. Yeah, I mean, how could you possibly have a house that would be mold-free or smell-free when you have a swimming pool for your wall cavity? That was just nuts. So yeah, go ahead.
I'm sorry. It's like, leading forward a little bit. So my biggest concern as a carpenter is less about the mold smell. I mean, of course, it's really important, but I'm really concerned about platform collapses.
Oh, yeah, I bet you've seen some things where. So does your company? That's what I was going to get to. A little bit about your own company? So you have the system. You know how to fix it. Do you have carpenters, or do you sub out? Do you actually fix the structural damage that was caused by some of these problems, replacing trusses, that sort of thing?
Yes. Yeah.
So you do that. So you don't just sub out to a flat, commercial roofing contractor, or you have crews that do that.
Yeah, I've got my own roofers. So
okay.
I've got two small crews. So let's put it in terms like this, where you pull back the membrane and the first thing you see is the water. So we solve for the water, right? So we pull it back further to replace the rotten plywood, and then we see rotten trusses.
So right under that rubber layer, you can probably see two or three layers of insulation, and underneath that, would there be how does that work? Is there the plywood decking? So if there's the rubber, there's the insulation, there's the decking, and then the decking sitting on the trusses. Is that fairly standard?
That's correct.
Okay. And the trusses you're seeing, well, if you're working on a modern building, are you seeing steel? Or if they're steel, they're probably not a problem. Are you seeing mostly like standard wood engineered trusses?
All engineered trusses. I have yet to open up a house that had metal trusses.
Oh, really?
Yeah.
So, and when these things are rotting, they're obviously rotting from the ends. Well, not necessarily. They could be rot in the middle, but if they're up against that wet masonry units, that's where they're rot. So that doesn't that just destroy the whole truss? How do you replace something where the ends are completely rotted out? Or do you build gussets, or what do you do?
Yeah. That's it's cool. It's because we can individually, on a small scope, we can individually repair trusses. So when we do a roofing job, the first thing that we do is we cut open the perimeter. We'll do maybe 12 to 16 feet in length of a parapet wall, installing our venting system. Now, our venting system is the sheet metal is capping off a gap that's where the roof membrane, there's a gap behind the roof membrane. The magic sauce is basically we use dimple board, half-inch polyiso. Half-inch polyiso is the binder for the roof. And here's a piece of the insulation board, and then we laminate dimple board to this polyiso.
Okay, so that's when you're holding a piece, it's about a half inch of iso foam with dimple board laminated to it, and that's your combination. Your company is the one who puts those two things together.
Correct.
Okay, and does it come in 4x4 sheets or 2x4, 4x8?
4x8 sheets.
Okay,
and then so. We'll install this venting system, but the nice thing about when we do the perimeter first is that we're not going to get our tail caught by tearing off too much and discovering a huge calamity. So we open up the perimeter of the roof first and do a site inspection on every single truss, because we need the venting system anyway, and then we also need a site inspection on every truss. So when we get to that point, then we can either repair individual trusses if it's not too much, but I had to invent a tent to cover these buildings so that we could tear off the entire roof system, all the plywood, and address the repairs as needed. So
I did see that tent on the website. So that tent is your invention. Do you sell those, or you make them and sell them?
We don't sell them yet. Hopefully that's on the horizon. We've installed about a dozen of these tents over the past couple of years. It's an aluminum adjustable rafters that we made. That we set one about every 8 feet, and we run 2x4s as purlins to support the trusses or those rafters, and then we wrap the whole building in boat shrink wrap.
Yeah, that's. I mean, it seems kind of extreme, but the process that you're talking about of fixing a large project like this is a several weeks or a month plus project, right? Mm-hmm. And then in the meantime, you can't rip something open and then have it rain on, I've done as a contractor, I've bid jobs where people want me to tear off the roof while they're living in it. And I said, I'm just not going to do that.
Yeah, right.
It's just, yeah. So this allows your workers to keep going.
Right.
Regardless. How do you keep it? How does the wind not catch that thing because I'm assuming you're up at least 3 stories, oftentimes more than that. How do you keep it anchored?
Well, we have a bracket that attaches to the inside of the parapet wall that's got a bend in it. So it's almost like a big Z bracket. So that bracket has a receiver for threaded rod that is actually, I've got the legs of my tent are actually half-inch threaded rod that fit into this bracket. It's kind of hard to describe. I'd like to, post a picture at some point.
Sure.
But high winds, we've been in several windstorms that hit 60 miles an hour.
And up in the air, they're probably more than that.
And it did move.
Yeah.
I've been in snowstorms, high winds, heavy rains, and
you're in the Chicago area, so obviously it gets pretty cold there. Does it hold heat well enough to make it? If it's on a 20-degree day, is it still halfway comfortable in there?
Right, because the heat's rising up from the house, and so it never gets below 40 degrees.
Oh, nice. That's not bad.
But we also have a 4200 CFM fan that's running at the gable end of our tent, so it creates negative pressure and helps to control the cloth from blowing.
Gotcha, from ballooning out.
Yeah.
Yeah. That's interesting. Yeah, does it take a full day to set that thing up?
It's a 2.5-day job.
Okay. But it's saving you, weeks, or up to, possibly weeks.
Well,
if not, probably.
The cost on a tent runs about $30,000.
Yep.
Well, the savings.
Well, these aren't cheap repairs you're doing either.
Yeah. So the savings for the homeowners over $100,000 because we're not opening and closing every single day.
Right.
And so this also enables me to really study the structure And we end up making all of our own metal brackets to support the trusses. So we cut the trusses away from the wall, block them out, not particularly in this order. We block them out first, laminate structural grade plywood to either side of the trusses, and then we bolt 1/4 inch thick 4x10 metal brackets that we have an array of holes that
like a U-channel type, bracket.
Like an L bracket.
Oh, okay. Yeah. Like one on each side, or just one?
One on each side.
Okay, cool. So it's a plywood gut. So at the end, you cut away or leave the rotten part of the truss, and then you put 2 new plywood gussets on either side of the truss, and then you have 2 L brackets that are bolted to the. Yeah, that sounds like a project. That is a project.
But I've got a buddy who he doesn't take that approach, and these other engineers, and they go ahead and remove all the trusses. My point of view is I want to try to add value, keep people in the house, don't blow out all the mechanicals. So we've been dealing with the ends of the trusses.
And you're right. It would be probably faster to just tear off the whole roof, replace the trusses, but that doesn't take into account of all the mechanical, the wiring, the plumbing, the people that live under it. Yeah. Oh, that's interesting. If you were to, so one thing I forgot to ask earlier, so we're talking about how bricks, and I've heard both ways, and from masons actually, saying, oh, you don't, even if it's a brick veneer, whatever you do, you don't want to seal this, seal the exterior of a brick because it doesn't let water out. So, I mean, when's a good time? When should you seal? Let's say you have a split face wall or a brick veneer, or a 3-story building with a CMU with a brick veneer. Should you always seal that exterior facade or not? Is that a mistake? Where do you land on that?
It depends on the age of the house, right? Okay, so you're talking newer contemporary.
Anybody that owns a house that has some type of masonry on it, stone, brick, whatever.
Okay, well, the old buildings with pure lime mortars, they work on their own quite nicely. It's especially if they haven't been, adulterated on the interior, any kind of remodeling, because it seems like whenever people add insulation to the inside of a masonry structure, then they block off that breathability of the building, and then they get mold. But the mold also occurs when the building's been repointed with harder mortars than were original, and that definitely drives the moisture in and causes issues. In that case, that's the only case in an older structure where I've been using a product called ChemTreat. It's a clear siloxane. It dries so you can't see a sheen, but at least it reduces the bulk water going into the side of the building. Otherwise, I wouldn't touch it if it's never been,
So if it's an old building and if it's even been repaired with the proper mortar, there's no reason to seal the outside of it.
There's no reason to seal it.
Okay. So when you do seal it, so how about the newer structures that you're working on? Do you seal? I mean, if you put that vent system in that you've created, is that good enough, or do you go ahead and seal the exterior as well? I mean, does that come into play with your whole how you do your repairs?
Yeah, I seal all newer buildings. That's my default. So you have to vent and then reduce the bulk water coming into the side, and then exhaust the water vapor that's naturally occurring, and that will give you a healthy structure.
If, speaking of healthy structures, if you could wave your magic wand and build the perfect structure that would be breathable, keep everybody healthy and dry and safe inside, what would that wall look like?
Okay, so if we're dealing with a masonry structure, right? And we get brick and block. So
let's say CMUs and with a brick veneer.
Okay, so we would lay up the block first as a complete unit, all the way up to the top, and then I use a variety of rain screen materials. In this case, there's a few companies. One, Mortar Net, not just the old process of mortar net, but they make a mesh that's got the fabric on the surface, just like Benjamin Opdyke, or there's a company out of Washington called Stuccoflex. So they all make the rolls of rain screen material. Like I've used the Slicker Max 2. I'm not getting paid to endorse them, but it's easily it's local in my market. So I use that product. So we put
Is
that.
this something are these products rolled on, or are they coming in sheets, like 4x8 sheets?
They're rolls of this material.
Okay.
It's like a big Brillo pad with the similar fabric that we use to keep water out.
Sure.
And so if you put that in between the brick and block, and then you put your brick ties over it as you lay up your brick and vent the top, you'll never have an issue.
So and then as far as insulation goes, just insulate the interior walls.
No, well, first on the inside of the block, I would run a dimple board all the way up to the roof system. So we're engineering an airspace. So that's the interior rain screen, and then from there you can use anything you want: rock wool, spray foam. Yeah, I've been hanging out with a lot of people from the passive house community, and so you can create a passive house even with you won't have any air infiltration as long as you separate your energy envelope from the structure. And the rain screen going all the way up to the top is critical. We did a job years ago, one of our early projects in Florida, and we used corrugated plastics on the inside of the wall. Before the drywall went in, this client was sitting on top of the parapet walls, and he felt the back of his leg started burning as he sat on top of the parapet. What he did is he discovered that the water that was in the wall was boiling and turning to steam, and instead of coming into the house, it would go into this interior rain screen and rising up out of the building. And
that's a good thing. I mean, that's a good thing, isn't it?
It was great. Yeah, it dropped the cooling load by over 20%.
Sure. Yeah, and so that interior screen, or so the trusses are attached to the wall, and that screen just goes around where the trusses are mounted, correct?
Right.
Okay. What am I missing? Actually, I've got a selfish question. So this might not be your cup of tea, but I've got I'm building a house right now. It's got a crawl space. It's almost like a full basement, but it's not high enough. It's just a big crawl space, storage space. And I've got regular CMUs, and they have a rubberized kind of coating on the outside, and you need an R10. It's going to be a conditioned space, but you need an R10 to just per code. And it seems like, I'm new to this area, but it seems like they're just spraying on some fire retardant rated spray foam, basically, to get that, like 1.5 inches maybe. They're going right to the interior of the CMUs. So is that a viable system? Is there a better way to do it? I mean, any thoughts on that?
Well, I have a block foundation at my house here in Chicago as well. It's a 67 ranch. So what I do is I ran dimple board up the wall, tied into the drain tile, and then I put 2 inches of polyiso over the top of that, and then my framing over the top of that. Now, I would love to exhaust that moisture to the exterior, but I really can't. So instead, I use a dehumidifier in that space.
Gotcha. And mine will be conditioned with it, and so that shouldn't be a big problem. But if this isn't going to be a living area, I mean, there's a living area above it, so we don't want any mold, anything growing. But so spraying foam, you would put it, even in my scenario, you'd put some type of dimple board or something between that foam and the concrete.
Exactly. You need the ability for that stuff to diffuse. It's always going to go to the drier area of your basement or that conditioned space. You have to you have to control it in that way.
Is there you mentioned split face. Is there any type of masonry that you like more than, I think you've mentioned you're not a big fan of split face. Is that true, first of all? And is there something you just would never put on your house or a building?
I would never use split face block. And it's fine for a Walmart.
So that's the one. Well, a lot of those are just precast tip-up walls, I think, at the Walmart, right?
Yeah, some are. I mean, there are several around us that have that, but it's got so much surface area that it's not the finished product. So if you're going to use block, use smooth block, a rain screen, and put brick over it, or put some kind of siding over it. That would be.
How about have you come into how does stone? Is stone similar to have you done any older stone houses, do they behave similar to like a brick house? As long as the mortar between it's breathing, it functions well, or is there certain kind of stones that, like a brownstone or something? How do those hold up compared to a brick?
They hold up great, but don't forget that the interior white is often common brick, and the mortar's all the same. So the vapor diffusion goes vertically internal all the way up to the top. So they have the same issues as a solid brick older building as well as stone.
Okay. What are we getting to the end? What did I forget? What else do you want to say?
I think we need to get the word out so people don't get hurt in the future. I mean,
and I'm sorry to interrupt, but that's one thing I was going to ask. Have we learned any lessons? I mean, do we now know that you shouldn't use this type of mortar, harder mortar on soft bricks, or are you still seeing it all the time?
It happens every day because the masons have a hard time getting the good stuff. So when they come here, they go to a standard supply house, they get typo, pointing mortar, which they say, oh, it's fine, no problem. But really, it's the world of pure lime mortars. You can get a hard mortar that's pure lime. It's just that we have to maintain, compatible materials.
So it's not. I mean, we're not any closer. We have to be hopefully a little closer, but it's still a major problem. These buildings are still going to have major water infiltration and mold issues because people apparently haven't got the message.
It's our masons are dying out, and the technology is changing. And so when I found this process of creating a gap and venting the top, that it drives it out. Well, I hope the word gets out and more people use the technique because it's fixing the buildings.
Yeah. Sorry to interrupt. Is there anything else you want to say?
No. I mean, we're seeing, we had a job one time where not too long ago, it was last year, where the client noticed some drywall was sagging in the ceiling of his roof system. So we got up there and the drywall wasn't really sagging. It was the plywood web TJIs were disintegrating, that they were shearing away.
Yeah, that's frightening. So this isn't, like you said, this isn't just a aesthetics issue or, just a moisture problem. This could be catastrophic. Have you seen any catastrophic failures?
Yes.
Really?
One client went out for drinks one night and he came back and his whole roof system was sitting on his pillow.
Wow.
And the building was 12 years old.
Wow, that's crazy.
I know.
Yeah, no, that's not good. Yeah, that's not good. Where can people learn more about what you do and more about your products?
Our website is WickRight.com or WickRight General Contracting. But if they just type in WickRight, they'll find us. And
that's WickRight, one word.
That's correct.
Okay. Thanks, Bob. This has been great. I learned a lot. You obviously know what you're talking about, and hopefully you can spread the word so we don't have people's roofs collapsing on them. That sounds like the moral is you should just go out for drinks more often, right?
Get lucky.
Right. All right. Well, unfortunately, that's all the time we have for today. Thank you very much for joining us, Bob, and thank you all for listening. Please remember to send us your comments, questions, and suggestions to fhbpodcast@taunton.com. And please like, comment, or review us wherever you're listening. It helps other folks find our podcast. Stay safe, everyone, and thanks again for listening.